three types of polygon problems you get in higher GCSE. There's the type where you have to find angles between the regular polygons. There's ones where you have to find angles inside a regular polygon where there's an isosceles triangle in play. And the hardest ones that you see, the ones on the right, are ones where you've got like a polygon inside a polygon, and that makes them the hardest ones to solve. For all of them, the easiest thing to do is to start filling in the angles. And the starting point for this is to think about inside a triangle, you have a total of 180 degrees. Inside a square, 360. Inside a pentagon, you have 540. A hexagon, 720. A septagon or a heptagon has got 900. An octagon has 1080. A nonagon has 1260. And a decagon has 1440. And that list at the left-hand side, as you work your way down that list, it's just increasing by 180 each time. That will get you 1 mark, guaranteed, in the GCSE exam paper. Once you can do that, you can start working on these problems. So if we start on these ones here, between the polygons, you're looking at here, a hexagon, here, a pentagon, and here, a pentagon. And the question would say that they're all regular polygons, which means all of their angles inside are equal to each other. So the best thing to do here is to start filling in the angles. For the hexagon, over here, we can see it's 720. If we do 720 divided by 6, we'll get each of these angles inside is 120 degrees. And you can write that on every single one. If you then go to the pentagon, pentagon over here has 540 as its total interior angles. 540 divided by 5 is 108. So you can fill that in on each of these pentagons. All the way round is a really useful thing to do. Once you've done that, you've got 2 marks on that problem, guaranteed. Now to find these 2 angles on the board, this one here and this one here, we just need to use some really, really simple maths. So, the one here, if you look, you've got 120 and 108 and the other part of 360. So you can do 108 plus 120 is 228. Subtract that from 360 and you'll get 132. That is the answer to that one there, 132. Same idea again, over here, you have 120, 108, 108, and this small missing angle here. Same thing to do there. Add up what you've got, 108 plus 108 plus 120. You get 336. Subtract that from 360 and you get the angle 24 degrees. So that one there. That's how you solve one of those. It'd be a grade 6 problem if you did it. And it all started with this left-hand side of the screen over here to get these angles on the inside over here, to then work with angles at a point, which are 360, here and here. And that's all you need to be able to do to solve that first problem type. The second problem type you can approach in exactly the same way. You look at the second problem over here, where there's an isosceles triangle inside the polygon. First thing we notice is it's a pentagon. The pentagon has 540 degrees in total. So the 540 divided by 5 gives us 108. That 108 is here. That 108 is here, 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 and here. All 5 of those angles are equal and they're 108. The angle it's asked us for, B, sits inside an isosceles triangle. It's isosceles because these 2 sides, here and here, are equal to each other. Because the pentagon, being regular, has 5 equal sides. So, that means in this isosceles triangle, angle B here and this one here are equal to each other. So to calculate angle B, we can do 180, take away the 108, gives us 72 degrees. That's these two angles together. Because they're equal to each other, an isosceles triangle, you need to divide by 2. So 72 divided by 2 gives you 36 degrees for that angle there. No different than the first problem. We used the information down the left. We filled in all the angles we could inside the pentagon. The key here was knowing it was an isosceles triangle and that these two angles were equal to each other. Then it became a much simpler problem. Third and final problem type. Again, we're going to go back to the starting point. This shape here is a hexagon. The hexagon, we know, has a total of 720 degrees inside, which means that one of its interior angles is 120. So this is 120, 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 and this is 120. That's our starting point, and it gets us 1 mark in the GCSE. The next thing we look at is the pentagon. This pentagon that's inside has a total, if we look over on the left, 540 degrees. 540 divided by 5 gives us 108. That means each of these angles inside the pentagon is equal to 108 degrees. The final part of this problem comes from zooming in here and looking at what's happening. You have inside the hexagon, as we saw, 120 degrees. You then see inside the pentagon, this bit here is 108, and it's the bit in between that we're trying to find. It's the overlap between those two. So our final calculation is the 120 that was here, take away the 108, which was here, that gives us the answer 12 degrees, which is the final part of the problem that we were looking for. All 3 problem types all started with this simple list, going up in 180s. They all involved filling in the angles inside, and they all involved using some simple angle rules like angles at a point, or isosceles triangles, or here, just looking at the difference between those 2 numbers. That will guarantee you can get 4 marks whenever one of these questions comes up.